Fine, great. So today, as we are going to start the subject fluid mechanics, okay? Fluid mechanics. First of all, before starting the subject, I would like to say something which are very important for studying the subject. As a teacher, what is the responsibility of a teacher? Anyone can tell me? Mr. Syan Mukherjee, what do you expect from me? Because it is a first class that I will only talk about the basic thing. What expectation you have for me, or what do you expect from me as a teacher? Very good, very good, Sambit. To make us understand all the concept, quality of education. Very good. Thank you so much, Ganesh. Everyone who are present here should answer, should give their responses. As Mr. Sambit said, to make us understand all the concept. Very good. Mr. Ganesh expect from me is the quality of education. Very good. Nandini is typing. Karthikeyan is also typing. Because it is very important to have a response from all the participants who are present here through online mode, clarifying the doubts. Very good. Now, but as a teacher, what should I expect from you people? Knowing the application of the concept from Nandini. Very good. As a teacher, what should I expect from you? The first thing, you should be regular and you should be a very attentive in the class. You must have some prerequisite knowledge. What do you know by prerequisite? Prerequisite means some earlier information that you must know before starting the subject. Yeah, response is also very important. Why the response is very important? Because when you will give your response, then it is a two-way communication. Because class must be a democratic class. What do you know by democratic class? Democratic class means where the opposition, or you can say here opposition is a student and here I am a ruling party. Ruling party and opposition both have equal opportunity to share their thoughts, their ideas. Clear? So first of all, how can I make the class democratic? By getting the response from your side only. It should not be like a chalk and talk. It should not be a one-way communication. It should be a communication from the two ways. And I am not going to teach you anything. First of all, we are going to learn here. That's first thing. I am not going to teach anything from my side. You will not get anything from my side. We will learn here. We will learn. Me and as a you people. है ना? Both will contribute our experiences, where our knowledges, and on this platform, and that will make us are learning a concept. Is this clear? Hello. हाँ नो, हाँ नो। नहीं नहीं, रात में नहीं खाएंगे, सुबह ही खाएंगे बस। हाँ ठीक है, ठीक है, थैंक यू। Is this clear? Now, and one the main important role of a teacher is not although clearing the concept, quality of education, clarifying the doubts, knowing the application of concept, all are very nice answer that you all have sent to me. But the one most important thing that you are missing, and that you must learn from all the teachers, is what? The teacher is a person who make you able to think. Are you getting a point? Apart from clearing the concept, quality of education, clarifying the doubts, knowing the application of the concept and all, it's very important to develop the ability to think. Is this clear? Means now you will a role of good teacher, a teacher, a role of good teacher is who makes you able to think. That's very important. क्लियर? तो हम सोच सकें, ऐसी चीज़ों को डेवलप कर सके, दैट इज व्हाट इज कॉल्ड एज टीचर. दैट्स मेन इंपॉर्टेंट फीचर ऑफ अ टीचर इज who makes you able to think, and that's what is missing in most of the teachers. So I am trying my best to develop these abilities. Along with these abilities, I will also try to give my best to make you think about the topics, to make you think about the concepts, to make you think about the topics, and you are able to connect with the practical real life applications. Clear? Now come to the subject that I am going to discuss here, that is what fluid mechanics. So as far as fluid mechanics is concerned, the first term that I will get here is fluid. So first of all, what is the fluid? The first question. Fluid is a substance which has ability to flow, which have a nature of fluidity. Means fluid is a substance which have ability to flow when it is subjected under the action of shear stress. Means when the fluid is subjected under the action of shear stress, it will get deformed. It will get continuously deformed. That is called as fluid. Clear? So first of all, as I will discuss here, what is the fluid? Fluid, it is a substance that undergoes continuous deformation very good, very good. But Mr. Sian, I would like to add one thing. You know that undergoes continuous deformation, not deformation. It is a substance that undergoes continuous deformation under the action of applied shear stress, immaterial of or independent of how small magnitude of shear stress is. Clear beta? Any problem? Tell me. Fluid is a substance that undergoes continuous deformation under the action of applied shear stress, independent of how small the magnitude of stress is. Means even the smaller magnitude of shear stress can cause continuous deformation, that is called fluid. Clear? So why I have written here continuous deformation? That line is very important. Not deformation. This is what continuous deformation is there. That's what is important here. Fluid is a substance that undergoes continuous deformation when it is subjected under the action of shear stress or shear force. What is shear stress? I will discuss it. So if anyone asks you what do you know about the fluid, then fluid is a substance that undergoes continuous deformation under the action of applied shear stress, immaterial of magnitude of the stress. Okay? So now, how the fluid is differ from the solid? And listen, here we have applied the stress, and stress causes deformation. Deformation is called strain. Yes or no? Deformation is strain, and stress is proportional to strain. It's also Hooke's law, and Hooke's law is applicable to the solids. So if we have a solid, and if we apply some shear stress over the surface of solid, that also undergoes deformation. Yes or no? That also undergoes deformation. Then how the solids differ from the fluid, or how the fluid differ from the solids? Mr. Sian, anyone? If you define the solid, solid is a substance that undergoes deformation under the action of applied shear stress. But in the solid, deformation is not continuous. There is a definite deformation is there. There is a definite deformation. For the given shear stress, for the applied magnitude of the stress, the solid undergoes a definite deformation, while the fluid undergoes continuous deformation. Yes, very good, Sambit, excellent. Solid absorb, not oppose, you can say oppose also. Solid absorbs the applied shear force or stress under the static equilibrium condition. Yes, very good. While the fluid absorbs the applied shear stress under the dynamic equilibrium condition. Yes, very good. Clear? So you can say when we apply the shear stress over the fluid undergoes continuous deformation. Means there is a strain rate, not only strain, there is a strain rate. While in the solid there is a For a given applied stress, there is a definite amount of strain, not rate of strain. Clear? So if you see, let's say this is what the fluid element I have considered here. This is what the fluid element. And let's say this fluid element is confined between the two parallel plates. Two parallel plates. It's a fluid. When we pull the top of the plate with some force F, let's say S, shear force. What shear force I will discuss here. Then what happened? This is the initial position 1, 2, 3 and 4. When we apply the stress, then the fluid undergoes 2 prime, 3 prime. Again undergoes 3 double prime, 2 double prime. Means you can see the deformation is continuous. Are you getting a point? Means if you see, that was the fluid element 1, 2, 3 and 4. The initial condition. When we apply the stress over it, some shear force we applied, then that undergoes a deformation. You can see this is the amount of deformation is there. It's 2 dash, 3 dash. And with respect to time, as long as the stress has been applied over it, this undergoes a continuous deformation. 2 double prime, 3 double prime. Again it undergoes 2 triple prime, 3 triple prime. Clear beta? That undergoes continuous deformation. Very good, Shyam. Anyone? Is this clear? As long as the stress has been applied over the fluid element, that fluid undergoes continuous deformation. While in the solid, when we apply the stress over it, that solid undergoes a definite deformation. So this is what the fluid. Now if you talk about the solid, let's say it's any metal block is there or it's a solid, and when we apply some shear force over it, then what happens? It's 1, it's 2, it's 3, it's 4. Then for the given applied stress, that 2 dash and this is 3 dash, that is only definite deformation is there. Deformation is not continuous. It's only definite deformation is there, and that's why it's called as stress proportional to strain. Clear? Clear beta? So as far as difference between fluid and solid is concerned, first fluid, and here I will write as solid. It undergoes continuous deformation under applied shear stress. It undergoes definite deformation under applied shear stress. Here second point, it is the first point. Second, fluid absorb, it absorbs the applied shear force or stress, you can say force point area is called stress, shear stress. It absorbs the applied shear stress under which condition? Dynamic equilibrium or static equilibrium condition? It absorbs the applied shear stress under dynamic equilibrium condition. Why dynamic? Because force is balanced. Whatever force you applied, that force will absorb, but that force will be absorbed by the fluid under dynamic equilibrium. Why? Because the deformation is going continue. That's why it's called dynamic equilibrium condition. While the same is there, it absorbs the applied shear stress under static equilibrium condition. Clear? Any problem? Under static equilibrium condition. Now, third difference that you can write here is when you remove the load over the fluid, when you remove the stress over the fluid, what happened? Is it possible for the fluid to regain their original shape or not? Anyone else? Not possible. Mr. Sambit, suppose for example, if water is there and if you blow air over the top surface of water on the first, then as long as you are going to blow the air, the fluid will get continuously flow, है ना? But if you stop blowing the air, what happen? Is it possible for the water to regain its original shape? Yes, solid can regain its shape either fully or partially depending upon the applied stress is beyond its elastic limit or below its elastic limit. Yes or no? If the applied shear stress is beyond the elastic limit of the solid material, that will not get its original shape. But if the applied stress is below its elastic limit, then that solid will regain its original shape either fully or partially. Yes or no? So on the removal of applied shear stress, the fluid will not regain its original shape. Exception is viscoelastic fluid. Do you know? The one exception is viscoelastic fluid. Which has property of viscosity as well as elasticity. One exception is viscoelastic fluid. An example of viscoelastic fluid is anyone? Do you know any fluid when we remove the load over it, when we remove the stress over it, that fluid will regain its original shape? That fluid is called as, yes, fluid in ligament, that's called as Vianial fluid. Yes, very good. Flowed off, very good. Flowed off, आटा आटा का जब आप छोड़ो, प्रेस करो, फिर छोड़ दो, तो अगेन इट विल ट्राई टू रिगेन इट्स ओरिजिनल शेप. वेरी गुड. ठीक है. तो ऑन द रिमूवल अप्लाइड स्ट्रेस द फ्लूइड विल नॉट रीगेन इट्स ओरिजिनल शेप. ओनली एक्सेप्शन इज विस्कोइलास्टिक फ्लूइड. You can write from your own. Exception is but Rashi, rubber is not the fluid. Rubber is the solid. I am talking about the fluid, beta. Clear? I am talking about the fluid. Solid will obviously regain its original shape, either fully or partially. For example, the best example that you can see here only, you can take a book on your palm, and upper palm you should apply a stress. That you can see your book will get deformed. So as long as you have applied the shear stress through your palm on the top surface of the book, then book will deform, and deformation is definite. Am I right? But as you remove the load over it, if you remove the palm over the surface of the top surface of the book, then book will again regain its original shape. Yes or no? So I am talking about the fluid. Fluid in general will not regain its original shape when we remove the load over it. And the only exception is viscoelastic fluid, which can regain their original shape, and that fluid is viscoelastic, which has property of elasticity as well as viscosity. And that example is fluid in ligament, bionial fluid, and other example is flowed off. Now, while in the solid, it will regain its original shape either fully or partially on removal of shear stress. Clear? No, honey. No, madam. If you apply the shear stress over honey, the honey will go flow. Honey will get flow, not the honey. No, madam. If suppose if you take a honey on the table, and you will apply shear force by your finger, then what happen? It will deform. If you remove the load, will the honey will regain its shape? Clear? So what is difference in the fluid and solid? Is this clear? That's a basic difference. Now, what is fluid mechanics? As the subject is fluid mechanics. What do you know by mechanics? Yes, very good. A study of forces. So you can say fluid mechanics is a branch of science and engineering that deals with the behavior of fluid at the rest or in the motion. Very good, Shreyans. So in this subject, what we are going to study? In this subject, we are basically going to deal the behavior of the fluids either at the rest or in the motion. Clear? So, as far as definition of fluid mechanics is concerned, it is the branch of science and engineering, because engineering is nothing, it's just an application of science, है ना? So that's why it is the branch of science and engineering that deals with the behavior of fluid that deals with the behavior of fluid at rest or in motion. Clear? Simple. So fluid mechanics is the subject that deals, it's a branch of science and engineering that deals with the behavior of, study of, that deals with the study of, with study of behavior of fluid either at rest or in the motion. Clear? And we'll also discuss all the governing laws that are associated with the fluid either at the rest or in the motion. It also involves, or you can say in other words, it involves study of all the governing laws, all the governing laws associated with fluid either at rest or in motion. Clear beta? What the fluid mechanics is actually? And as far as application of the fluid mechanics is concerned, it will be very unfair if we have to discuss about the application of the fluid, because our daily life, our life is full of the application of the fluid mechanics. Yes or no? We as a person living in the ocean of the fluid, in air, in our body, the bloods are moving in the veins. Blood is also a part of fluid, example of fluid. Yes or no? Yes, even we are alive due to only fluid. We are living in the ocean of, we are living in the ocean of air, which consists of oxygen and nitrogen. And for living, it's very important to absorb the air through our respiratory system and absorb the oxygen and remove the carbon dioxide. That's what the function of respiratory system. Yes or no? So again, the fluid is flowing through the respiratory systems. In our veins, the blood is flowing. So there are various example applications of fluid mechanics is there. That's why it's very basic subject. Okay. Now, the fluid mechanics as a whole is very wide, vast, and that's why what's how we can classify the fluid mechanics. The whole subject of fluid mechanics we can classify in following three categories. One is fluid static, fluid kinematics, and fluid dynamics. Clear? The fluid mechanics can be divided into following three. One is fluid static, fluid kinematics, and other is fluid dynamic. Clear? Fluid static, which involves the study of all the governing laws that are associated with the fluid at the rest. What the fluid kinematics? It involves the study of motion. It involves the study of velocity and acceleration of the fluid particles. And fluid dynamics involves study of forces that causing the motion. Clear? So it is simply a broad classification of the fluid mechanics. Any problem up to this point? So what fluid static deals? What does fluid static deal? Fluid static involves the study of governing laws associated with the fluid at the rest condition, like hydrostatic law, Pascal's law. Yes or no? Fluid kinematics involves the velocity and acceleration, means it involves the study of motion of the fluid particles. Because kinematics means study of motion. And since fluid kinematics is there, it means it involves the study of motion of the fluid particles, which involves the velocity and acceleration. Fluid dynamics is involved study of forces that causes the motion in the fluid. Means it involves the study of forces. Clear? Any problem? Tell me please. Any problem, beta? Now, very good. Now I define the few terms here. If you see shear stress, before going details about the shear stress, first of all I would like to discuss about the stress. So write down heading is stress. What is stress? Anyone? How can you define the stress? So force applied on the object, it is a force. How can you define the stress? Yes, force acting per unit area, not tangential. No, 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 no. Janvi, it's wrong. Tangential force applied on an object. So stress is, I think, stress is the stress has unit of force. Stress have unit of pressure, I think. Na? It's a Newton per force per unit area. If you see the dimension of stress, what is stress? Stress is force per unit area. So which force I'm talking about? Tangential? No. No. Listen, what the stress is? Let's say if I am going to talk about any arbitrary object is there. Or better is that, let us consider like this. This is any arbitrary object I have considered. Over this object, I just consider a small differential element, dA. This is any arbitrary object I have chosen here. Over this, I just assume a small differential area is dA. Clear? And this is what the force acting on this object is this. It's F. F is the force acting on unit area is what? dA. And it's a very differential force delta F. Delta F is what? Differential amount of force which are acting on the element. And if we resolve this force into two, one is normal. Let's say this is the normal component. Then, and this is what tangential component. Two component of the force is there. One is normal and tangential. In normal direction, the component of the force is, let's say, del Fn. In tangential, the component of the force is del Ft. Clear? So the force which are applied on the unit area or a small differential elemental area dA, the force is delta F. That force we can resolve into two directions. One is normal, other is tangential. The normal component of the force acting on unit area of the element is called as normal stress. The component of the force, what is delta Fn? Anyone? Delta Fn is nothing, it's a normal component. Normal component of force acting normal component of the force acting is called as normal force. Delta Ft is the called as anyone component of the force acting along the plane or parallel to the plane or tangentially. Tangential component of force acting called as tangential force. Clear, beta? Or you can say the component of the force acting along the plane of area dA, along the plane. Clear? Along the plane means like this. Along the plane. Normal and along the plane or parallel to the plane, you can say also. It's called tangential force. So they are the forces. Now from these two forces I got the two stress, because stress is nothing, it's a force per unit area. Now depending upon the which types of force is there, tangential force or normal force. So here I am going to define one is called as normal stress, and that is nothing in the limit of delta A tends to 0, means delta F normal upon delta A, means force acting on unit area of the element is called as normal force. Clear? While shear stress is called as tau, which is in the limit of delta A tends to 0, delta F tangential upon delta A, this is called as shear stress. Clear? This is called as normal stress, and this is called as shear stress. Now you can define what the shear stress is. Shear stress is what? The force which are acting along the plane or parallel to the plane or in tangential direction on a unit area of the element is called as shear stress. And when it is acting on the normal to the plane, it's called as normal stress. Any problem? Tell me please. Clear? My dear student, if you are going to consider any rectangular fluid element like this, if you are going to consider rectangular fluid element, over this rectangular fluid element, if I am going to draw like this, listen. Now you can see how many faces are there? 6 faces are there on this rectangular element of the fluid. Yes or no? Tell me. There are 6 faces. Over the 6 faces, if I am talking about, let's say this is what the y, let's say this is called as y, this is called as x, or generally it's called as z here. This is what is called a y. Let's see. Here I would like to define different component of the stresses. How many component of stress are there? Anyone? And tell me, is the stress is vector or scalar or tensor? If you see, there are 6 faces are there: left, right, top, bottom, front, back. What is tensor? Anyone? What do you know by tensor? We have already heard about the vector, scalar. How the tensor is different from the last two, vector and scalar? Yes, very good. Magnitude plus direction plus plane. It means along with the magnitude and direction, you must also define the plane over which it is going to act. Okay, Mr. Abhishek, means of on which plane it is going to act, because you can see here there are 6 planes are there. So over which plane it is going to act, you must also specify. Yes or no? So listen here. As far as I told you in the last lecture, in the very before starting this subject, I have given you some homework. You have to come with the revision of stress, vector, scalar, and tensor. Yes or no? And one more thing you should write here. Now, you know what is the direction of normal stress? Normal stress when the fluid is at the rest condition. Try to understand here. In a fluid at the rest condition, normal stress is called as pressure. That you must know, when the fluid is at the rest condition, that normal stress is called as pressure. Clear? So normal stress is not equal to pressure for all time, but normal stress is only equal to pressure when the normal stress is acting on the fluid at the rest condition. Clear, beta? So you can write this point. In the fluid at the rest, normal stress is called as pressure. And when the fluid is at the rest condition, there is zero shear stress. There is zero, no shear stress is there when the fluid is at the rest. Because shear stress causes deformation, and when the fluid is the rest, then there is no deformation. Means when the fluid is confined in a container, obviously that wall of the container will not allow the fluid to be moved. So in that case, the shear stress is zero. So when the fluid is at rest, means shear stress only going to exist when there is deformation is there. Am I right? As long as deformation is going to be observed, then only you can expect the shear stress. So when the fluid is at the rest condition, shear stress is zero, and the normal stress is called as pressure. Clear? And listen, when suppose this is what the container is there, है ना? And when you fill the liquid here, for example, liquid. In a glass, water is filled here. Here there is no deformation is there. So in this case, shear stress is zero. So when the fluid is at the rest, shear stress is zero. But in this case, the applied normal stress is called as pressure here when the fluid is at rest. And when we are going to tilt the container, what happened? When we are going to tilt the container, the shear develops, and the liquid splashes or moves to attain a horizontal free surface. Yes or no? So when the shear will develop, when we are going to tilt the glass or container. Clear beta? Now come to the component of shear stress that I studied here. Actually, the stress we are going to represent by tau ij. I am talking about shear stress ij. What I indicates, what j indicates, that's very important here. I is what? I, where I indicates where subscripts I indicates the face on which the stress act. Where J subscripts identifies the direction of stress on that face, on face I. Clear? The tau ij, I indicates the face, or you can say the plane. Face you can say, or you can say the plane. Face or plane on which the stress is going to act. Which stress? Shear stress. J indicates the direction of stress on the face, on the plane I. Is this clear? So J indicates direction and I indicates you the plane. Clear? Any problem? In total, there is a 9 stress component. In total, there are 9 stress component. It's just a basic. Where 6 is shear stress. Shear stress that I told you earlier. What is shear stress? The shear force acting per unit area. And 3 is the normal stress. 3 component is of normal and 3 component is of the shear. Clear beta? Now listen, where are those 6 plus 3 or 9 stresses are there? Listen carefully. How can you identify the plane, first of all, or face? Listen, this is what is called as beta. This is called positive x plane. Here, if I am going to write separately, my dear student. This is, and if it is my axis, is like this, z and x, and this is what is y. So since it is in positive x here, this is the plane. Any, let's say this face is perpendicular to the x coordinate, yes or no? That's why name is called as positive x plane. This is called as positive x plane, and this is called as negative x plane. Clear? How we define the plane? Is this clear? Positive x and negative x plane means we are talking about on this plane the direction of the stress. So what is positive x, what is negative x plane? Is this clear? It is a plane, both are x plane. How will you decide the plane? Is this clear, beta? Mr. Abhishek, others, Rashi. Why it's positive? Because it's a positive direction, and this is what in negative. Now tell me about this. If I'm going to use the red color here, now tell me, what about the top red and bottom red? Anyone? What about top red and bottom red? Which one is top red? Is top face is not positive. Why, sir? It is z axis. Yes, it's a positive z plane, and this is what negative z plane. Clear? What about front and back? I am going to show you here. Y-axis. I am talking about this is what z and this is x. When I will change the coordinate accordingly, the plane will also change. Yes or no, beta? I am talking about this one, and this one. Now tell me, this is called as positive y, and back is called as negative y plane. Yes or no? Very good. Clear? Now let us suppose I am talking about let's say z, x and y. I am talking about this plane and this plane only. Over this plane, I'm talking about plus x. है ना? Very good, Rasi. And shear stress always acting along the surface or normal to surface? Tell me. Shear stress always acts along the surface or normal to surface? Always act along the surface, or you can say parallel to surface. Very good. So on this face, if I'm talking about this, what is this here? On it means this is the stress acting along the plane, but in which direction? Along which plane? Positive x plane. In which direction? Tell me please. In which direction it is going to act? In z direction. So it is called as tau xz. Am I right? Tau xz. Means on x plane, on positive x plane in positive z direction. Yes or no? Then in order to be in equilibrium, on this face it is going to act in this direction. It's also tau xz. You can see x plane, negative z. Yes or no? What about this? Again, you can see this again along the surface, parallel to surface, but this is what tau x y. Yes or no, beta? Tau x y. X plane, positive x plane, then positive y direction. And here you can see this is a negative x plane, then negative y. Negative y is here in this direction. It's tau x y. Am I right? So listen, what I'm saying to you, for positive shear stress, listen, for positive shear stress, what the condition is that direction and plane, either both direction and plane either should be both positive or both negative. Or negative. What does it mean here? It means direction and plane both should be either positive, both should be negative. Then only the stress value is positive. Is this clear? For example, in this case, the value of stress is positive. Why? Because direction is negative. If you see, the plane is what? Plane is negative x, and direction is what? Negative z. Negative plane, negative z, it becomes positive value of shear stress. Is this clear? Here, negative x and negative y, it will again make a positive value of shear stress. For negative shear stress, direction and plane should be different. Am I right? Should either direction and plane should be different sign. Clear? Any problem? Now come to the, so that's why you can see in defining the stress along with the magnitude and direction, the plane is also important. For example, here it is a shear stress in z direction, but on which plane? X plane. If I am talking about the front, listen, if I am talking about the front here, this front means what? Positive. I am talking about y plane. On y plane, if you see, my dear student, on the y plane, tell me, it's a plus y plane. For the positive, if plane is positive, then direction should be also positive for the positive shear stress. What about this here? What about this? And what about this? ये क्या है? Tau on y plane, but that's in what? Z. So you can see tau yz and tau xz. Tau yz and tau xz, both are acting in the same direction but on different plane. Both the stresses are acting in z direction but on different plane. That's why the shear stress is a tensor quantity. Yes or no? Bolo beta. Here one more stress is going to act here. It's called as tau. Plane is what? X, and direction is also x. Plane and direction both are same. If you see on this plane, if I'm talking about, let's say this, I have drawn separately this plane. So you can see this one, you have seen this one, you have seen this one. This is what tau xz, This is what tau xy, and this is what tau xx, and tau xx is called as normal stress, normal in x direction. Is this clear? Tau xx, x plane and x direction. Is this clear, beta? When the plane and direction are the same, that's called as normal stress. Same thing if you see on the front side. On the front side, here you have seen, this is what tau yz, and this is what is called as tau yx. But again, one more is acting here, normal, it's tau yy, and tau yy, which is means in y plane, in positive y direction, this is called as normal shear stress. Clear, beta? Bolo. So you can see, if you observe these two shear stresses, so in this shear stresses, direction is same here, magnitude even may be same here, but what the difference is plane over which it is going to act. So the tensor are the quantities which requires magnitude, direction, along with this the third quantity that must be required is what plane over which it is going to act. Clear? Mr. Shan Mukherjee, any problem, beta? If you write all the component of shear stresses, then here tau x, tau xy, tau xz, tau yx, tau yy, tau yz, tau zx, tau zy, and tau zz. If you see, these are called as anyone. 9 stress components are there. Tau xx, tau yy, and tau zz, they are called as normal stress. And the rest all called as shear stresses. Clear? So what is the meaning of, if I am writing here tau xy, what does it means here? It means that stress is going to, this is a shear stress which is going to act on the x plane in, if positive x plane, then positive y direction, negative x plane, then negative y direction, if I am talking about positive value of shear stress. Clear? So always shear stress is going to act. For example, the best example of shear stress is what? If you rub your hand, if you rub your palm over the another palm, and if you allow the move the upper palm over the lower palm, that causes the shear stress, because the force acting parallel to the surface, along the bottom palm. Yes or no? Is this clear, beta? That is shear stress. If you again want to clear more, what is shear? Shear means what actually? The relative displacement of one layer of substance over another layer is called as shear. Clear? Means Its shear is nothing, it's called as a relative displacement of one layer of substance over the another layer. For example, let's say if this is one block of the solid and there is another block of the solid is there, and it has a velocity of 2 meter per second and it has a velocity of 1 meter per second, then if you see with this, you can see the upper layer A and B means the material A have a relative displacement over the B, yes or no, and that called as shear, that called as shear. Clear? Means again you can see this, some force is going to apply to cause the shear, and that force is called as shear force. So what is shear force? Now shear force, the force that causes, the force that causes shear called as shear force. What is shear stress? The shear force acting on unit area is called as shear stress. Clear? बोलो बेटा. Shear stress, everything is clear? Rashi. Isn't it? Shear stress, component of the shear stress. Is this clear? Now, how will you decide direction of shear stress? Listen. रेडी हो या नहीं? Now let us see. I would like to decide some example here. Let's say you have a plate is there, and over the plate the fluid is flowing. I told you in the fluid in the heat transfer, fluid is flowing over the flat plate, and this is what the velocity distribution we got here. Yes or no? And here u is a function of y. It is a y direction, and it's a velocity axis. So velocity of x direction is going to vary in the y. Yes or no, beta? And there are different layers of the fluids are flowing with different velocity. At the bottom layer, velocity is 0. As you move away from surface, the velocity of the fluid get increases. Is this clear? Now, if I am going to consider a plane or surface C, let's say this is imaginary surface C is there, C and C dash. It is an imaginary surface that I have considered here. Let's say I am going to red color, C and C prime. It is an imaginary plane or imaginary surface. and it is a distance from here, from the bottom is YC. At YC distance, C is the plane that we have considered here, and its distance is from the bottom is YC. Clear? So if you see above the plane, the two layer of the fluid is there. One is this one, and other is this one. Two layer of the fluid is there. Yes or no, beta? So what I'm saying to you, on the upper surface of the plane C, on the upper surface of the plane C, any fluid flowing above the plane C, this is what the fluid layer. This fluid layer will apply shear stress on the upper layer of the plane C. Yes or no? Similarly, any fluid layer flowing below the plane C will apply the shear stress also on the bottom layer of the plane C. So what I'm saying to you, the fluid above Y equal to YC, the fluid above the Y equal to YC, above YC will apply the positive shear stress. Why positive shear stress? Because if you see, this plane is positive plane, this plane is positive. Now how can I say the plane is positive? You should draw normal. If normal is going to in positive Y direction, this normal is in positive, and here normal is in negative. Yes or no? If I'm talking about the upper layer of the plane C, then this is what the positive Y, positive normal means positive Y plane, yes or no? So in positive Y plane, for the shear stress to be positive, what the directions would be? Positive X. So this is what the direction of the shear stress is going to act on the upper layer of the plane C. Is this clear, beta? Tell me. So the fluid above, the fluid flow above Y equal to YC will apply the positive shear force on the upper surface of plane C. Yes or no? Tell me. And what is direction? The Y direction is here because I am talking about positive shear stress. Then positive shear stress means to acha. So positive Y plane, then positive X direction. I told you for shear stress to positive direction and then both will be positive. Okay, what about the shear force applied by the bottom fluid? Now from the fluid behind Y equal to YC or below will apply shear stress in which direction? Negative direction. Why? Because if you see for the in this, my dear student, this is what the negative Y plane, but negative direction should be there and negative X is here. Clear? So from the fluid behind Y equal to YC or below Y equal to YC will apply an equal and opposite force should be applied to become in equilibrium. will apply equal shear force in negative direction, and these are, if you exaggerate, if you see, this is the plane here. Over the plane here, the direction of shear force is here, and here direction of shear force is here. How I decide direction? Is this clear? Tell me. How I decide the direction? Is this clear? This is the what? Plane C and C dash. How I decide the direction? Is this clear? And why equal and opposite force will apply? To become the layer plane to be in equilibrium. Clear? Now at the same time, I would also like to ask you one more thing. Rasi, one more thing. Let's say this is what the two, one more example. Don't worry. Let's say you have a plate, clear? And here the fluid is confined between the parallel plates. Here the fluid is there. Top plate is moving with the velocity v, and here it is a stationary plate. It is stationary, and this is a moving plate. Clear? Now, if this is what the velocity, this is what the, how the velocity will vary. Yes or no? Here the velocity is 0 beta, and here velocity is the upper layer have velocity of the same as the velocity of the plate. Yes or no? If I am talking about what is the direction of shear stress applied on top and bottom of the plate, Rashi, this is just try to understand the condition. I have two parallel plates, and between these two parallel plates the fluid is filled. Let's say water is there, and top plate is moving with the velocity b, and bottom plate is stationary. Since bottom plate is stationary, means if you draw the velocity profile, then at y equal to, it's a y direction here, at y equal to 0, velocity is 0. As you move along the y, then velocity get increases, and at the top the velocity is same as top layer of the fluid will gain the velocity of the top plate. Yes or no? In this case, what we would find out? We would find out what is the direction of shear stress. Clear? On the top and bottom of the plate. So if you see, let's say I'm talking about on the bottom plate. So on the bottom plate, if I want to find out direction of shear stress, what I will do? I will just simply draw a normal. Normal is in positive y and negative y. Tell me. The normal that we have drawn, this normal is in positive y or negative y? The plane is positive y or negative y? Positive y. Then for the positive value of shear stress, what the direction should be there? If the plane is positive, then direction should be also positive. Yes. Then this is what the direction is there. This is what the stress. Now come to the top plate. On the top plate here, if you draw on the top plate the stress which has been applied by the fluid. So if I draw here, this is what negative y or positive y plane. Negative y. Then for the positive value of shear stress, what should be the direction? Negative y or negative x or positive x? Plane is negative y, so direction should be negative. This is what the, yes. So this is what the direction of shear stress is, tau. Here tau. It's a tau yx. Here also tau yx. So this is how we will decide. Means here, in this case, the shear stress is going to act in this direction, and here shear stress is in positive x and here negative x. Reason is clear? No, sir. Shear stress cannot be zero, sir. Sure. Sir, how it is possible to zero shear stress, sir? So fluid is at the rest. Am I agree? But the upper layer, any layer above this will move in, that causes the shear stress over it. Because shear stress is what I told you. The relative displacement of one layer of the fluid over the other layer is called as shear stress. The relative, when there is a relative displacement of one layer of the particle over the other layer, that causes the shear. And when, if you observe this, then even the two layer, if you see carefully, if you magnifying the glass, then what you will find? The up one layer of the fluid is moving over other layer. One layer has zero, the other layer has some. This causes the shear stress to be developed. Is this clear? Now, is this clear all about shear stress? I will discuss when I will discuss the viscosity and all. ठीक है? Okay, sir. Sir, what I told you. I told you for the shear stress, if you are going to consider shear stress as a positive value, है ना? Then obviously for the fluid to be in equilibrium condition, I told you ना कि when you apply the shear stress, the fluid will absorb the applied stress under dynamic equilibrium condition. I told you. So equilibrium is always there, means force is always balanced. What is meaning of equilibrium? Means there is no imbalance of forces. Yes or no? Sir, if we are taking, this is all direction I have told you when we are going to consider the positive value of shear stress. When we are going to consider negative value of shear stress, what happened? How we got the negative value of shear stress? When the plane and direction will be different. Yes or no? Means plane is positive, then direction is negative. When plane is negative, then direction is positive. Clear? In the same problem, I can also write the direction in the same problem. Listen. Mr. Karthikeyan, you can remember just like this here. The two layer of the fluid is there. If you recall through this example, Rashi, two layers of the fluid is there. One have the different velocity and other have different velocity. Then what I did here, I just choose one plane over it. So any fluid layer, this is the plane under consideration. I am talking about the direction of the shear stress applied on this plane by the bottom layer and top layer. Means above the plane C, any fluid moving above the plane C and any fluid moving below the plane C. Is this clear? The two layer of the fluid is there. In between two layer, I just consider an hypothetical plane. Clear? Oh, what I want to find, I want to find out what is the direction of shear stress applied by the fluid flowing above the plane C and by the fluid flowing below the plane C. So in starting I told you we can write the shear stress either in positive or in negative. When how it is possible to have positive shear stress when direction and plane both should be positive. So what I will do here, on this plane, if you see, if you draw, I'm talking about top of the plane C, on top of the plane C. So this is what the positive y plane. Positive y plane, then for the positive value of shear stress, direction is what? Positive x. So this is what the positive x is there. Similarly, if you draw here, then this is negative y plane. Then for the shear stress to be positive, then this should be direction should be reverse here, negative x. At the same time, on the same layer, C and C dash, if I am talking about negative value of shear stress, then this, it's a positive y, then positive y, and if I want to have a shear stress to be negative, then what should be direction? For negative shear stress, let's say I am talking about negative shear stress, then what should be direction? It's positive y, then direction should be negative of x. And here it's a negative y, then direction should be what? Positive x. Then this is what, yes, clear. So only the thing is that here the value of stress is negative and here value of stress is positive. That's it. Clear? And to be in equilibrium, equal and opposite force should be applied, and that causes the shear force to be developed. Now is this clear? So this is what the shear stress is. Now everything is clear about the shear stress. Stresses, yes, either you can make a positive or negative value of shear stress. Is everything clear? Now we are going to discuss here properties of the fluid. Fluid properties. Now, because as we are going to discuss the fluid, then it is very important to understand about the properties. Which properties of the fluid do you know? Anyone? Tell me the name of the properties that do you know. The first very important basic property is what? Density. And density is of two types, mass density or molar density. Very good. Second is what is called as do you know what is relative density? Also called as specific weight. What is specific gravity? What is, do you know by specific gravity? A relative density means density of one fluid with respect to the standard fluid is called as a relative density or called as specific gravity. Third very important property is called as weight density. Mass density, molar density. One more is called as weight density. Mass, molar and weight. Any other property that you know is viscosity. Very important. Very good. Viscosity. Viscosity. Surface tension. Compressibility. Compressibility. And in fluid mechanics also we can, or you can say, define bulk density. Although both are inverse to each other, but in thermodynamics we are used to define the compressibility, but in the fluid mechanics we define the compressibility in terms of bulk density. Okay, the density is specific gravity, viscosity, surface tension, compressibility of bulk density. Any other property? I think that's are enough. These are very important properties of the fluid that you must know. First of all, if you go for density, a shear stress is not a property. It is not a property, sir. Now, first I am going to discuss here density. In general, density is nothing, it's mass per unit volume. So let's say if I have a container, if I have a glass, and I told you this is of 1 liter, and I told you just find the density of the water. How can you find? If you fill this with the water, then you know the volume of the water is 1 liter, obviously, because the glass capacity was 1 liter. How can you find the density? Anyone? How will you find the density? If you weight, if you know the mass, if you know the mass of the fluid, how can you find the mass? Let's say with empty container the mass was 1 kg, and when we fill the water the mass I found 5 kg. Means how much mass of the water is there? 4 kg. So mass upon volume will give you density. Means how much mass of the fluid is there in a given volume is called as density. Clear? If there is more mass in a given volume, it means density is higher. If less mass is there in a given volume, means density is lower. Yes or no? Am I right? So this is actually called as mass density, beta. Mass density. At the same time, there is a molar density. Molar density. So mass density we are used to represent as a rho. Rho is simply mass upon volume. And in SI system, its unit is what? Kg per meter cube. In CGS system, what is the unit of density? Tell me. Gram per centimeter cube. Am I right? In FPS system, what is the unit of density? It should be foot pound second, means pound lb mass per feet cube. Yes or no? Now tell me, what is your molar density? It's represented by rho m. Rho m is nothing, it's a mole per unit volume. How much moles of the fluid is there in unit volume? This is called a molar density. And if you want to know the relationship between the mass density and molar density, is very simple. because since mole is equal to mass upon molecular mass, yes or no, then you can write the molar density, you can represent this is mass upon volume upon molar mass. This is what is called as beta rho m is equal to simply rho upon m. So molar density equal to nothing, it's a mass density upon molecular weight. Am I right? Clear? It's simply mass upon molecular weight. Clear, Sian? Now, tell me about the weight density. Weight density. This would be weight of the fluid upon volume of the upon volume. So weight is what? mg upon volume, or mg upon v. M upon v is called as beta mass density into g. So rho into g is called as weight density, and that is represented by this gamma. Clear? Rho g. Now it is clear, Mr. Sian? Now, if I am talking about effect of pressure and temperature, effect of pressure and temperature on density of gas, on density of fluid, let's say first of all, for gases, if gas follow ideal gas law, if gases are ideal gas, then they will follow P equal nRT. Yes or no? Then what is the N upon V? It's called as molar density. Molar density is nothing, mole upon volume, N upon V, and this is what P upon RT. So if you see, the density of the gases is directly proportional to pressure and inversely proportional to temperature. And also rho is equal to mass density, and molar density, what I told you, mass density nothing, it molar density into molecular weight. Then you can write here P into M upon RT, where M is the molecular weight. Yes or no? So if you see, as far as effect of pressure and temperature is concerned, the density is directly proportional to pressure and inversely proportional to temperature. Yes or no? For the gases I'm talking about. Because when the pressure increases, then density increases. When temperature increases, density decreases. Means, as far as density proportional to pressure and inversely proportional to temperature. Means when temperature is higher, then density will be lower. This is what I written for gases. Clear? For liquids, now for liquids, it has been observed that density is again inversely proportional to temperature. but there is no any specific relationship is there, but it is found from the experiment that density is inversely proportional to temperature, again just like similar to the gases. As temperature increases, the liquid become lighter, and that you can do experiment if you want to heat the honey. If you heat the honey, then that honey density become lower. Even the water, if you, same is with the oil, you might have seen, if oil is there and if you heat the oil, it become much more thinner. Den- as temperature increases, density decreases. Density decreases means what? In a given volume now less mass is there. So try to think. Clear, beta? And as far as effect of pressure is concerned, Mr. Karthikeyan, it has been observed that effect of pressure on the liquid density is generally negligible, independent of pressure. Until unless the pressure is not very high. Very high. Clear? Any problem? So this is what is called as density. Mr. Karthikeyan, any problem? For gases, density is proportional to pressure. More the pressure, more the density at a given temperature. At a given temperature. As far as liquid is concerned, the density is independent of pressure. Density is independent of pressure, and as temperature increases, density decreases. Inverse, just similar to the gases. Now the last, but not the least, I am going to discuss here is a relative density. Or specific gravity. SG. It is a ratio of density of a fluid to the density of a standard fluid. Density of the fluid to the density of a standard fluid. Is this clear? Or also you can say or weight density of the fluid to the weight density of standard fluid. Both are same because Gg cancel out. Yes or no? What the standard fluid is? The standard fluid for liquid is water at 4 degrees Celsius, and at 4 degrees Celsius the density of water is 1000 kg per meter cube. And for gases, tell me anyone, for the gases, what is the standard fluid? Very good, excellent. Thank you so much, Samit. A standard fluid is air at STP, standard temperature and pressure condition, and here it is around 1.003 kg per meter cube. In general, we should write 1.0 approx kg per meter cube. No, not 1.21. At STP, it's you can calculate approximately 1 kg per meter cube. Clear? So, if you want to know the specific gravity of any of the fluid, then you should divide the density of that fluid with the density of standard fluid. Clear? If the fluid is liquid, then you should write the standard fluid density as 1000, and if fluid is gas, then you should write the standard fluid as air, and whose density is 1 kg per meter cube. Clear? Is this clear, Rasi? So that's all for today. I think I told you the topics in more clear way without any doubts. Yes or no? तो कुछ समझ में आया? The new thing. Speed was good or moderate or fast? Speed was slow, moderate or fast? Tell me. Slow. Moderate. Okay. मतलब it was good ना? Thank you so much. By tomorrow we'll meet at the same time. It will be very interesting. Oh, thank you so much. Thank you so much. Good night.